Alright, so just before I get started, I wanted to let you guys know that the app that I'm using to create this video sort of does weird sounds with the audio, so hopefully it doesn't sound like it's shaking too much. But so if you do hear that sound, I'm aware of it. It has to do with the app that I'm using, and I don't know how to fix it. So this was this was an assessment that was covering angle relationships and triangle inequality. So let's go ahead and start looking at the first two questions. So on number 1, it's asking you to draw the triangle after you've done the two transformations that are listed right here. So it says translate the triangle 8 units to the right, and then you're going to reflect it across the x-axis. So I'm going to highlight the x-axis because I just want you to be aware that is the line that you are going to make a reflection across. And I'm going to do that after I translate the triangle. So in order to move it 8 units to the right, you just put your pencil on the 3 vertices and you move it 8 units to the right. So starting at the top, 1, 2, 3, 4, 5, 6, 7, 8. So here's 1 point. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There's another point. And here's the other point. So that's our triangle. I'm not going to connect the points yet because I want to reflect it first before I connect it. That way you can see what it'll look like as the final product. So in order to do a reflection across the x-axis, you're going to count how far away the 3 vertices are from the x-axis. So for example, if I'm looking at this point right here, I want to count how far away am I. So I'm 1, 2, 3 units above the x-axis. So if I want to make a reflection across the x-axis, I'm going to go 3 units down. So that's 1, 2, 3. So that puts me right here. And then for this point over here, I'm 2 units above the x-axis, so I'm going to go 2 units below. That takes me right there. And then the other one, I'm 2 units below, so now I'm going to go 2 units above. And I'm going to try to connect these points to create my triangle. So that was number 1. Okay, if you hear scratching right now, that's my cat, and he's being ridiculous right now. Alright, so that was number 1. You just needed to draw the triangle after the 2 transformations. Question number 2 is asking you to describe the transformation algebraically. So there's multiple ways that you can do this. So here, if I'm moving to the right, that means that I'm going to be affecting the x-coordinate because the x-axis only goes left and right. So if I'm moving 8 units to the right, that would be in the positive direction, so I'd be adding 8 to the x-coordinate. So here I'm going to have x plus 8. And then when I'm making a reflection across the x-axis, that's causing my triangle to move either up or down, right? So whenever we are moving the vertices of the triangles, we either move them up or down. So that would affect your y-coordinate. So what I did is I'm changing the sign on the y values. Now, if you didn't realize that that's how you did it, you can look at one of the points that you have. So for example, this original point that you had on the triangle was -5 and 3. -5, 3. So now you're going to look at the point that corresponds to that point and see how it changed. So for example, this point, the final point that we got, is now at 3, -3. So here, if we look at what happened to the x-coordinate to get from -5 to 3, I can do -5 plus 8. That gives me a +3, which is the x-coordinate right here that I got. And then here, all I did was change, it's the same number, all I did was change the sign. So instead of being a +3, it became a -3. And that's one way that you can show your algebraic representation right here. Oh my goodness, thanks. Okay, so number 3 says use angle relationships to label the measure of each angle formed by the transversal in the diagram below. So these two lines are parallel to each other. Transversal is this line right here. That's the transversal. So the angle that's vertical to the 127 is this one right here. That one's also 127, so they're congruent. And this is also 127. That is corresponding to the original number that was given to us. And then that's vertical angle with the 127 that I just wrote. So then to find the missing acute angle that goes with it, since it's a linear pair, you know that you can subtract it from 180 degrees. So when we subtract, we get 53. So each of these angles are 53 degrees. The 3 acute angles. There's 4 acute angles. And majority of you, I think, did really well on that question. Number 4 says, what is the name of the angle relationship that is illustrated? So these are called vertical angles. That is the name that you would give them, vertical angles. Some people would say, well, they are congruent angles. And yes, that's true. They are congruent. However, when you say the word congruent, that's more of a description. That's more of a way to describe them because they are going to be congruent to them. But if you want to name them, you could say that they're vertical angles. On number 5, it says, what is the name of the angle relationship illustrated here? So similar to what I was just saying on question 4, these angles are congruent to each other, but that's a description. So if you wanted to name them, you would name them corresponding angles. And number 6. What is the name of the angle relationship here? So I saw some people write supplementary. If we wanted to describe these two, you could say that they are supplementary because they do add to give you a sum of 180 degrees if this is a straight line. But the best way to give them a name would be to say that they are a linear pair. Because they lie on the same line, on this line right here. All right, let's look at the next questions. Number 7 says, using your knowledge of interior angles, determine the measure of angle M and explain how you came up with that. So this is a typo. angle M. It's just asking you to find the measure of X, the missing angle. So I'm going to erase what I just did right here, but so M is referring to X. So the first step that you would want to do here, and by the way, when it says explain, you can do two things. You can either explain by showing your work very clearly so that I can see exactly all the steps that you're following to get to your answer, or you can, use sentences and write it out that way. So, my first step that I would do here is to solve for this missing angle right here. So, because it is a linear pair with this exterior angle of 45 degrees, you would subtract from 180. So when I subtract from 180, I get 135 degrees. Okay, now what I would do is I would have to figure out the total angles inside of this polygon. So I want to figure out what's the sum of the interior angles. So the sum of the interior angles can be found by, there's two ways. So you can ask yourself, how many angles are inside, or I'm sorry, how many triangles are inside of this polygon? I'm trying to write it more clearly. So let me try to see if I can draw that the best I can. So you would choose one vertex. I'm going to choose this one right here. And I'm going to add lines to connect all of these other ones to that one. And if you see, it's creating several triangles, right? So how many triangles do we see? 1, 2, 3, 4, 5, 6. So there's a total of 6 triangles inside of that polygon. Okay, so what do we know about a triangle? We know that a triangle has a sum, the interior angles has a sum of 180 degrees. So if I were to multiply 180 times 6, you would get 1080. Now, I think I told you that there are two ways that you could have solved this. So the first way, or one of the possible ways, was to create all of the triangles that are inside of this polygon. The other way is to use the formula. So the formula is n minus 2 times 180, where n represents the number of sides. Well, how many sides are on this polygon? If you count, you're going to find that there's 8 sides in the polygon because it's an octagon. And so what would that cause you to do? If you're following this formula here, you get 8 minus 2, which is 6, and 6 times 180. We just found that, right? So that's where that formula is coming from. It's looking at the amount of triangles that are inside of the polygon. Okay, so let's go ahead and continue to answer the question. We want to figure out the measure of angle X. So I'm just going to erase this to make it a little bit less distracting. So what we would do is we would add up all of the angles that are inside of the polygon that were given to us. So I'm going to add 142 plus 107 plus 125 plus 125 plus 150 plus 135 plus 162. So if I add all of those together, I get 946 degrees. So if we know that the total has to be 1080, and so far I have 946 degrees, I would just subtract to solve for x. And if you do that subtraction, x is 134 degrees. All right, let's look at number 8. Number 8 says, this is a regular polygon. Determine the measure of angle y and explain how you came up with that. So, again, you can follow kind of the same steps that I just went over on number 7. You can try and calculate how many triangles are inside of the polygon. So what you could do is you can add the side, or figure out how many sides we have. Oh my gosh, my cat is being so loud. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this has 12 sides. So if I use the equation n minus 2 times 180, so 12 minus 2 times 180. So that's 10 times 180. Oh my goodness. So that's 1,800. So if I have the sum of 1,800, now what I would do is I would divide by 12 to figure out each of these individual angles on the inside. So if I divide this by 12, I get 150 degrees. Now, that doesn't answer the question. The question is asking about the exterior angle y. So if it's a linear pair, all I would have to do is subtract from 180. So 180 minus 150 gives us the answer of 30 degrees. Now, the way that I just solved was involved a little bit more steps. It got me the same answer, but it involved more steps, as opposed to if I knew that the sum of the exterior angle for any polygon, the sum of the exterior angles is always going to be 360 degrees for any polygon. So if I want to figure out what one of them is, angle y, I would divide by the amount of sides that I have, right? So if I divide that by 12, I'm also going to get 30 degrees. That's a much faster way of doing the same problem, but you know what? Either way gets you the correct answer. All right, let's look at number 9. So number 9 says, archaeologists unearthed parts of 2 adjacent walls of an ancient castle. Before it was unearthed, they knew from ancient texts that the castle was shaped like a regular polygon. But nobody knew how many sides it had. Some said 6, others 8, and some even said 100. From the information in the figure, how many sides did the castle really have? Why do you say that? Okay, so I would use the same idea that I just kind of went over in question number 8. We know that the sum of the exterior angles is going to be 360 degrees. And if I take 360 degrees and I divide it by the number of sides, which in this example, that's what we're trying to figure out. We want to try to figure out the number of sides of the polygon, right? So if I take 360, divide it by the number of sides, that would give me the amount of one exterior angle, which was given to us right here, 24 degrees. So we're going to have to use algebra to manipulate. So I'm going to say that this is x, what we're trying to solve for. So what we could do, if we set this up as a proportion, you could cross multiply, but essentially what we're doing is we're going to do 360 degrees divided by 24. That gives us x. So when you do that division, you'll get 15 sides. Now another way that I saw some people doing it, they were doing it the triangle way and just doing trial and error. And they knew that like here the inside angle was going to be 156 degrees. That's another way of doing it. It's going to be a longer process. But either way works. All right, number 10, last one. If two sides of a triangle measure 8 and 19, the third side must be between blank and blank. All right, so when you are given two sides to a triangle, the third side must be longer than the difference of the two numbers. So let's go ahead and subtract. When we subtract, we get 11. So it has to be, so let's say x has to be longer than the difference. So it has to be bigger than 11. Okay. But it also has to be shorter than the sum of the two other sides. So let me add these numbers. So when we add these numbers, we get 27. So it has to be shorter than 27. So those are my two numbers, 11 and 27. It's pretty simple. All you're doing is adding the two sides that were given and subtracting the two sides that were given. And a better way to write this inequality would be to write it like this. So so 11 is less than x is less than 27. So realize that the side cannot be exactly 11 or exactly 27. It has to be in between. So like 11.1 or 26.9 would work, okay? So it can't be exactly 11 or exactly 27. I hope this was helpful for you guys. Have a great day.